Hello, everybody. My name is Sergey. I work as the penetration testing team lead at Scientific Cybersecurity Association, and I'm also the lecturer at Caucasus University. Today, in my speech, which is called Building C2 Servers for the Assessment of AI-based Antiviruses, we are going to speak about the C2 servers, their architecture, how they can be used. We will also have demonstration, the analysis of the methodology, and the ways to bypass the antiviruses. From the beginning of the technology era, there are cyber criminals which are trying to steal the data by using the malware, and there are the blue team members which are trying to protect the assets with the antivirus solutions. Before we even speak about how these solutions can be bypassed by hackers, we have to understand how do they even work. Most of the cases, the antiviruses, be they regular antiviruses or AI-based antiviruses, consist of two parts, which is static analysis. It's the part of the antivirus which looks statically on the binary file, looking for the known signatures, keywords, or maybe some specific Windows API calls. And there is the dynamic analysis, which runs the executable file in the restricted environment and checks what exactly does the file do. For example, maybe the file does code injections, or maybe it tries to change the registry, or maybe it tries to encrypt all the files on the file system. If the antivirus detects this, it will flag the file as malicious. What can hackers do in order to bypass the antivirus? There are a couple of techniques. Let's start with the simple, for example, the obfuscation. During the obfuscation, the code is being shuffled, some additional parts are added, but the main execution loop is the same. This is effective against the static analysis, but it's absolutely useless against the dynamic analysis. There is a bit more advanced technique like encryption, when the file is being encrypted, and it consists of two parts. One part is the encrypted body, and the second is the decryption cycle. So when the program starts, it deciphers itself and then executes. This is also very effective against the static analysis, but totally useless against the dynamic analysis. Next, there are really advanced techniques like the process halving, when the legit process is being run in the suspended mode, then its process memory is being replaced with the malicious payload, and then the process continues the execution. This is effective, but incredibly hard to implement in most of the cases. There is a question: can we make it simple? Because all of the code injections is rather difficult. The simple answer is yes. Let me introduce you the concept of the rogue software. The rogue software is the software which looks legitimately, but it is not legitimate, and it has some malicious functionality, though it has to be triggered by some event. Until the until the executable is triggered, it's not doing anything malicious. Let's bring some examples. For example, if we take the really legitimate program like the browser, it's the program that everybody uses on a daily basis. It's the tool using which we can ask the web server for the web pages, right? We are sending the HTTP requests, we are getting the responses. Absolutely legitimate. But what if we create the malicious browser, which also communicates with the web server, but instead of legitimate web requests, it gets the commands and sends back the results of the commands. The browsers are not malicious, but we can make the program which acts like browser and is malicious. So we can successfully bypass the antivirus. Using this kind of files, we can achieve, yes, of course, before we carry on, how to develop this kind of programs. We can use compiled programming languages like C++, C, or C#, or any other of your liking. And utilizing the knowledge, we can build the so-called C2 beacon. We will speak about this in a couple of minutes. So using this malicious programs, what hackers can do, most of the cases, it's so-called reverse shell, when the victim sends its terminal to the hacker, and the hacker can control the victim using the straight channel. This is rather noisy and can trigger the antivirus. The more smart approach would be to use the C2 infrastructure, which looks like the following. We have the attacker, we have the victim on the left side, and on the top we are having the C2 server. Step number one, the victim is being infected by the beacon, which is the malicious program. Step number two, we are registering the command that we want to execute on the victim on the C2 server. Then the victim asks the server for the command. It executes this command and brings back the response to the C2 server. This is a bit more stealthy and a bit more used approach in the wild. Of course, it's a better idea to build our own C2 server because a lot of the C2 servers that already exist, like for example Covenant or Cobalt Strike or the Empire, they are well known. They do have well-known signatures, or in some cases, if the C2 server is not well known, it might have the backdoors. By writing our custom C2 server, we are getting rid of known signatures. We know that it's 100% safe, and it's our own C2 infrastructure. We, in our research lab, did exactly that. We built our own C2 server, and we built our C2 beacon, the malicious program, which is capable of bypassing the AI-based antiviruses. Next, let me move on the demonstration in which we are showing how these programs are working. Here is the web page of the C2 server. The C2 server is web-based and written in PHP. Right now, we are going to pass the authentication by writing our login and password. And here is the main dashboard in which we can create the beacons. This will be done right now by clicking the button. Here is the beacon which is being created. This is simply the executable file, which we have to place somehow on the victim machine. Here is the link. And we, in this case, are going to use the Python server to serve it. Though in real life scenarios, we might use the phishing email to deliver the malicious file. After this, we are taking a look at the antivirus, and we are proving the point that the real-time protection is on, and the antivirus is the latest versions. After this, we are going to the web page and downloading the beacon file. Here, as you can see, we had other successful attempts. Now we are going to scan the file to make sure that the antivirus does not flag this file as malicious, and we are bypassing the static analysis. As you can see, the 0 threats are found. Moving next, we are executing the file. This page here does not relate to the antivirus. The Windows protects the computer by flagging this file as unknown publisher. This has nothing to do with the antivirus and can be easily bypassed. But for the sake of the lab, we left it as it is. As you can see, the black window appears and then it disappears. The victim does not see anything else. But if we go to our C2 infrastructure and wait for a couple of seconds, because the beacon communicates to the server once in some period, maybe once in 10 seconds, or maybe once in a minute. It really depends on the configuration. Here you can see the victim IP address from which we got the connection, and we can see the date at which the connection was made. Now we can try to execute the commands. Let's pick some really simple command like who am I, which is going to be executed. Now the beacon, a malicious program from the victim, is going to ask for this command, and after the execution, it's going to give us back the result. And here is the result of the command. Here is the NetBIOS name, and here is the username on the behalf of which the process was running. And now let's try to execute other command like system info, which is also really popular. And let's wait. I will skip the video to the point. Here you can see the results of the command. Next, to prove the point once again, we are going to hack the host machine from which the video was recorded. We are creating another beacon. Next, we are downloading it. We are downloading it to the machine, which is the Windows 10 machine from which the video was recorded. It has the Bitdefender antivirus enabled right now, and it's the latest version. If we scan the file, As you can see, the antivirus does not flag this file as malicious, and if we execute it, yes, once again, this window, we will run it anyways. Nothing happens at the first glance, but once again, if we go to our C2 server, we will see in some amount of time, here is the IP address of the new victim, and here was the time. We can execute the whoami command, and we will get the response back. Here, as you can see, is the response. And just to prove the point, we are running the command line interface on the hacked Windows machine and running the same whoami command to prove that the results of the command is the same. So we pretty much got the command execution on the victim machine, and the antivirus does not flag this as malicious. Be it the regular antivirus or the AI-based antivirus, by following this approach, we can bypass both antiviruses. When we can use this kind of techniques in the red team assessments, in pen tests, in experiments or scientific researches. And to speak illegal stuff, we can perform the information pillaging, data extraction, or the data destruction. But of course, as I have already said, it's strictly illegal. Moving next, let us conclude. There are possibilities to assemble the C2 servers self-written, which will be able to bypass the antivirus solutions, be it the regular antiviruses or be it the AI-based antiviruses. We have performed the lab tests, and the results were spectacular. We resulted in 80% of the antivirus bypass on different antivirus engines. Thank you so much for your attention, and I will listen for the questions if you have any.